Hi, today we are going to see the topic on plotting using MATLAB, how we are going to use the MATLAB software to do the plots which we are going to use in similar softwares like Python, how we can do the data science plotting with the MATLAB also. And to say about plotting in general, we may have a number of data with us, like we may have the data of a particular system or particular data based on an area or based on a specific identity or on specific tag numbers. Likewise, we may have several number of items which will be used for analyzing the historical total utilization or the process which it has been carried out throughout. So the data which had been arrived or which has been calculated has can be represented in the two forms, like in 2D and in 3D. So in this presentation, we will be seeing about the plotting in 2D and in 3D, how it will be different. Okay, in 2D. In general, we know the 2D means it consists of two different axes, then like x and y axis, or x and z, or y and z axis. It may be differ based on two coordinate system. The total plotting will be done, and the different type of plotting which it will be occurred when we use the same in an MATLAB, we can see now, like surface generation. The surface generation is nothing but how, based on a two coordinate system, a surface can be generated, like a box can be plotted based on the coordinates of its axis, so that it can be created. It is not only a regular shape, an irregular shape also can be formed in a surface generation process in 2D generation. Whereas the shading interrupt is a function which is used for creating the surface with the shadings. Like you have been seeing the heat maps, where a certain area has been in the more or most occurred or recurrence in a particular domain, but when the impact is being reduced based on the uh, time period, or like the prolonged durations, so it will be based on the heat map. We may use the heat maps, so for that purpose we can use the shading purpose of plotting. And to say about the color bar, we have different types of color bar, like the same heat map when only the shading can be done, and then we can add a color bar for that. And the other color bar plotting, you know that we can plot the color bars. In earlier stages, you might have seen these color bars in a single stretch, like if it is being represented for an unique material on different period of time, how it is being reacted, or a unique material or a unique period of time different material has been involved. Likewise, the profit or what other analysis can be done, we can do with the color bar, or what are the total sort, we can sort out these issues based on these analysis and pictorial representations. And to say about mesh, in 2D, the mesh is in general, it will be used to classify a particular defined area into n number of segments. Like if you see this 0 to 1, this layer has been divided into n number of structures based on the fractional divisions. Like it has been divided in a particular perfect triangle, which we cannot be define, or which we cannot modify with our hands, but still it can be done using these software skills. Then in 3D, if we see the 3D line plotting, it is general, right? We have three different coordinate systems like x, y, and z. We have two different plottings. So once we plot it, what will be the solution there? That is said to be the 3D line plotting. We can frame some irregular structures like helical, circular, elliptical, or else we can do the straight line plotting with the three-dimensional axis also is possible in 3D line plotting. And to say about the scatter, uh, we have we can represent the different profile using the scatter. We can represent different data using the scatter, or we can represent an n number of variants using the scatters. Like Here, a profile of a volcanic rock has been defined using a scatter. Similarly, we can use the scatter to provide the surface profile of an land, like the how the land is being in an stratum, how it has been the cut and fill level to be introduced in that land. Like the scatter can be used to produce the profile of an particular area or selected uh, or unselected object. And to say about 3D surface generation, earlier we got on the 2D mesh generation. The similar purpose will use the 3D surface generation, where it has then another domain, another axis in the part of Z axis. So it will be more easy to view it pictorially than to explain in a theoretical manner. So this 3D surface generation helps an educator to involve the student to know how it will work. Since this axis has rotation axis, so the students get a chance to view all the axis, how it is being changed. Ways he can rotate from top to bottom, or he can rotate across 360 to see how it is being acted. And the patch is an surface based criteria of how we can classify for an object. And to say in clear, we can see an object like a box or a wall, whatever may be the object, the heat map or the classification based on the analysis of the data available, we can make it in differ. So the patch can be done. And to say about the mesh grid, similar to the surface 3D surface generation, it here you can generate it as a mesh, so that the particular in an 3D surface generation we may not see how it is being divided, but still in mesh grid we have a chance to observe how the grid has been divided in particular areas. So these are the different types, and yet more we have the contour as the scatter we have done to show the profile of an volcanic mountain. The contour shows the profile which is present in and around, either like as I said earlier, the landscapes can be defined using the contour. In similar scatter also we can do the same thing, whereas the contour has a continuity line which flows towards the path until where it falls. Like if you see here in this area, the path here it is different and the path here is different. The total the contour shows that here there is a deep, it is big, the hole is big, and whereas the depth of this area is narrow, it is getting reduced linearly, but here it reduced rapidly. So these such divisions can be seen in contour based plotting. And uh, until now you had seen the basic introduction on how the 2D and 3D plots has been done in MATLAB. In further, now we are going to see how we can use the MATLAB to develop a program for plotting these type of plots, and we are going to see how those functional tabs will be working for this type of plotting. Shall we? Okay. When now we are going to start our programming in MATLAB, how we are going to make a plot. Initially, we have the data of we'll go for an 3D view, like the direction X, Y, and Z. Now we are going to plot the axle, like axis in the -3, 1, and 3. Here we have used the split as colon, and the end statement. If we are not giving this semicolon here, it will consider the value of x is -3, 1, and 3. So we need to end the statement, and we need to provide the next coordinate of y. So once over we had provided the x and y coordinates, then we're going to make the mesh based on the provided coordinate system. So until now we had given the two-dimensional actual data like x and y, and to frame a grid based on the x and y axis. But as I said earlier, the creation of 2D it will be a bit easier, but we are going to see the 3D today. And to say the next axis, how we are going to add it is, we are going to frame the z-axis with reference to the x and y axis. It's your wish, you can give your actual data like z-axis also you can mention as the coordinate system if you have. And if you have some database based on your working data, you can use there's a command to import an Excel to the MATLAB and use those Excel tables to frame this type of figures, how we are going to see now. To open the tab of figure where it will be displayed, we need to give the command as figure. Since I had been practicing for the other topics, the figure on
if you are plotting the figure, it will display the tab which I have shown you now.
And if you are plotting the figure, it will display the tab which I have shown you now.
So once you had shown the tab, then next the figure tab has been opened. Now we are going to prepare and surface 3D surface.
Then next,
as I said, once you had mentioned your coordinate x, y, and z axis, then you are going to create a mesh based on the x, y, and z axis. And you are going to activate the surface platform like figure so that your platform, empty platform, will be generated. Once your platform has been generated, now you are going to make the surface to be prepared as with the preferred data which we had provided to the system like x and y and z. Based on those three data, we will be getting the axis data, and we can even provide the names of these x, y, and z axis by giving the command x label, y label, and z label of the names. We can provide like
x label, y label, and z label of
label
the names. We can provide like
of single. And we can name it as ascent
of single,
and we need to close it. So like when we are providing this type of data, we can see how it can be.
So
when the name will be displayed in the table, the graph. It will be displayed as an
the name will be
name of
displayed
the
in the
axis.
table. The graph,
and it is compulsory to close these lines, so the names will be displayed as an
it is compulsory to
in
close
the graph
these
as
lines.
we had
So
given
the
here.
names will be displayed as
Maybe anything like
in the graph
x,
as we had given here. Maybe anything.
Okay, like and similarly we can do for y. Just for your observation, I'm giving only for x-axis. We'll check here. Now, if you see here, it will be like x-axis.
We'll check
so,
here.
And I had said you earlier, like this is an rotatable plane where we can check our
this
actual data based on our input and how the surface has been created. So once we are in here,
based on our input and how the surface has been
if you
created.
see, it is the top face, how we can see from the top, and
if you see,
and we can go across 360-degree rotation in this plane. Irrelevant to your rotational axis, we can make any axis, and we can just go back to our home view by restoring the icon home.
Axis, and we can just go back to our home view by restoring
Now
the
we had a framed and surface with a mesh. How it will be in with the individual
now
grid
we
system.
had a framed and
Now we are going
surface
to
with
combine these
mesh,
grid system
how
into an
it will
unique
be in with the individual grid
unique
system.
single
Now we are going to
surface, like
combine these grid
how
system
it
into
will
an
be
unique
displayed without any
single surface,
grid
like
interruptions.
how it will be
So now we are going to make a
displayed
shade
without
throughout the
any
surface. So the command is
grid
shading
interruptions.
interrupt.
So now we are going to
So
make a
once we are
shade
given the
throughout the
command,
surface. So the
our
command is
diagram will change like
shading
this.
interrupt.
Earlier we had shown
So once we had
the
given the
grids has
command,
been displayed here,
our
but now it
diagram
is
will change like
moved.
this. Earlier we had
Right?
shown the
Now
grids
if
has been
we
displayed
rotate it,
here, but now
we
it's
can see
moved. Am I right?
the total axis.
Now if
As I
we
said,
rotate
it
it,
is 360-degree
you
rotation.
can
You can
see
rotate anywhere
the
in
total
any
axis.
angle.
As I
So
said,
it is
it is
easy for
360
you.
degree rotation. You
Just to
can
get return to
rotate
your own
anywhere
view, you can
in
use
any
the
angle.
home button.
So it is easy for you.
And the
Just
next
to get
thing
return to your own
to
view, you
add
can
an
use the
color bar
home
for
button.
this particular
And
thing,
the next thing
like
to add an
you
color
can
bar for
add
this
color
particular
bar.
thing, like you can add color bar.
The color bar command, if and it is the MATLAB is user friendly, so that if we are doing some mistakes,
If
it
and it is
highlights
the
us.
MATLAB is user
And
friendly, so
if
that
you need
if
an
we
help data,
we are
you will
doing
be
some
getting
mistakes,
your help
it
here, like
highlights
some
us.
basic commands,
And
like
if you need an
what are
help
the
data, you will
mistakes we are
be
doing.
getting your help here,
Now, if
like
you have
some basic commands,
seen
like
here, like check
what
for
are
missing
the
argument,
mistakes we are doing.
the function is
Now if you
incorrect.
had
That means
seen here,
color
like
is
check for
not been
missing
completed.
argument,
The function has been
the function is
this
incorrect. That
particular
means
argument is incorrect.
color is
It need to be
not been completed.
completed,
The function has
so that
been
the
this
error had
particular
came,
argument
the
is
output had
incorrect.
not been occurred.
It need to be
But once
completed,
the actual
so that
programming code has been
the
given
error
here,
had came, the output has not
then
been
now
occurred.
our color
But
bar
once
has
the
been
actual
introduced here based on
programming
the
code has been given
heat
here,
scale or the
then
variance
now
of
our
data.
color
We
bar
can
has been introduced
identify
based
the
on the
scale
heat
with
scale or
our
the variance
reference
of data.
lens.
We can
And to say about the
identify
next
the
thing,
scale with
we can
our reference lens.
change
And to say about the next thing,
this
we
3D
can
into a mesh.
change
Earlier we had shown a grid surface, then we
this
had shown
3D into a mesh.
the surface to be
Earlier we had
shaded.
shown a grid
Then
surface.
now we are
Then
going to
we had
see
shown
how
the
this
surface to be
shaded surface
shaded.
can be changed into a
Then
mesh surface
now we are going to
without any
see
shading.
how this shaded surface can be changed
So
into a mesh surface without
like
any
this,
shading.
we can do the
So
data analysis,
for
like
this,
surface preference, and
we can
how
do the
an
data
particular data
analysis
can be
on surface
defined,
preference,
or particular data
and
can be used
how an
uh,
particular data
by
can be
reducing our work
defined,
time
or particular data
manually.
can
We can
be
use
used
these MATLAB software
uh, by
to
reducing our work
reduce our
time
time and work
manually. We
efficiency. We
can
can
use these
produce the
MATLAB
data in
software
more accurate, like
to
how it will
reduce our
be
time and work
there
efficiency.
in
We
an
can produce the data in more
actual real-time
accurate, like
applications. And
how it
to
will
say
be
about
there in an
plotting in data science
actual real-time
is
applications.
a
And
major
to say
plays
about
a major role, like
plotting
collecting
in
more
data
number of
science,
data, like 10,000.
is
Now
an
we had
major
done only
plays a
two
major
or
role,
three
like
coordinates based
collecting
system we
more
had
number
done
of
here.
data, like
But
10,000.
in data
Now
science,
we
we will
have
be
done only
considering
two
more
or
number
three
of, that is
coordinates based
n
system we
number of
have done
data,
here.
like
But
10,000 or
in data
12,000, or
science, we'll be
it will be
considering
in
more number of, that is
in
n number of data,
multiples of
like
thousands
10,000 or
or multiples
12,000.
of lakhs.
It
So
will be
that
in
much data can be
multiples of
easily
thousands
made
or
here
multiples of lakhs. So that much
for
data
analysis.
can be easily made here for analysis. Like we can do the scatter analysis, what type of data we require, what by range, by the source, by the analysis of a particular domain, like which we can use this software to explore more and to get ready for those contents. Thank you for listening this session, and thanks for, and I hope you have understood how you can create a 3D plot, and how you can create a 3D plot using MATLAB. And thanking you all. Thank you.